Okay, ladies and gentlemen, this is part 2 video for section 2.1. We're going to begin by talking about the correlation coefficient, which you will see abbreviated with a lowercase r. And what it does is tell us how good a given regression equation is. The closer the correlation coefficient is to 1 and -1, the better fit your regression equation is to the data values. So you notice here, if I draw in a line of best fit, you see how those points are basically right on our line of best fit. So this is a very, very strong positive correlation. Strong because the points are like almost right on the line of best fit, and positive because as I look at it from left to right, I'm increasing. A strong negative correlation would be right down here. Again, strong because those data points are kind of right on the line of best fit. Negative because my points are decreasing as I look at it from left to right. Alright, so basically a correlation coefficient close to 1 or -1 assures that our regression equation is a good model to use to make predictions with. Alright, and so in this slide here I kind of explain what I just went over. It's also important to point out this last part here, that correlation. So just because there's a strong correlation between one variable and the other doesn't mean that one causes the other thing to happen. Alright, they're kind of two separate things. Alright, let's do an example here. We're going to use the data in the table to write a linear model for demand in boxes sold per week as a function of the price per box in dollars. We're then going to describe the strength and direction of the linear correlation, then use the model to predict weekly cereal sales if the prices drop to $2 or raise to $4 per box. So we have a lot going on here. Alright, and before you begin, alright, I want you to get your calculator and turn it on, and we got to make sure our diagnostics are on to ensure that when we calculate our regression equation that the correlation coefficient comes up. So I want you to hit second 0. That's your catalog, and you're going to scroll all the way down to where it says diagnostics on. You're going to hit enter. It'll then show up on your screen. You'll hit enter again, and it'll say done. You've reached, or when you've done that step, you've done your job. Alright, and we can kind of start this problem now. So the first thing we're going to do is write a linear model. So we've done this throughout the year so far. We're going to take these points, plug those points into your our L1 list, take those and plug it into our L2 list. Alright, so what you want to do right now probably is press pause and get those entered into your calculator. Okay, once those are into your calculator, what you want to do is then go ahead and hit graph. So you've hit graph, okay, and then if you cannot see your graph, you want to go to hit the zoom key at the top, and then go down to number 9 where it says zoom stat and hit enter. Alright, and now you should see something that looks like, you should see a graph that looks something like this. We can now describe this. We can describe the correlation here. So without even looking at the correlation coefficient, we see that these data points are kind of clustered around very closely clustered around the line of best fit. So we have a very strong correlation here, and since these points are decreasing from left to right, it's negative. So we have a strong negative correlation. Alright, now let's calculate our model. And so this is in the shape of a straight line. So what we're going to do is we're going to hit, quit out of here, we're going to hit Stat, Calc, and then we're going to go down to LinReg and hit Enter. And then you're going to type in your L1 and your L2 list. Make sure you separate those with a comma. And this is what you should see on your calculator. So let's write our model. Our model is going to be y equaling negative 15,358.93. Let's round to 2 decimal places. Plus 73,622.50. So here is our linear regression line. That's our model that we're going to be using now to make predictions. How accurate are those predictions going to be? Well, we can be fairly confident that it's going to be accurate because our correlation coefficient is negative 0.98. So it's very close to negative 1, which is good. So in this next step here, when we're calculating the how many boxes of cereals, what are we going to do? When we're calculating the boxes sold, as we adjust the price per box, we can be fairly confident in our answer. So I'm jumping around here, sorry about that, but let's answer this final question. So use the model that we just got to predict weekly cereal sales if the prices drop to $2 or raise to $4 per box. So we're just plugging $2 and $4 into our linear regression equation. So if the cereal boxes are being sold for $2, you can expect to sell a total of 42,900 boxes. If you raise the price of cereal to $4 per box, obviously you would expect to sell much less. You'd expect to sell, in this case, 12,190, approximately that many boxes. Alright? Okay, next example. In example 6 here, now we're going to be using this same model from example 3 to develop a model for weekly revenue generated. Get rid of this. This isn't important. So develop a model for weekly revenue generated cereal sales, and then determine the maximum revenue and how to achieve it. Alright, so we're going to need, don't want to delete that. Alright, so revenue. What is revenue? Well, revenue is how much money a company is bringing in. So how do you calculate the revenue? Well, the revenue is going to equal the price per cereal box times the number of boxes sold. That gives you the amount of money you're bringing in. So that is going to be represented by X times Y. Alright, so my Y is represented by this equation here. So I'm going to take this and multiply it by X to write my model for weekly revenue. So we're going to have R of X equaling X times, actually I'm just going to, oh, okay, we're good. Alright, so we're going to multiply that whole equation by X. So R of X is going to equal negative 15,358.93 X squared. So plus 73,622.50x. So this is my model, and notice that it is quadratic. Now, the next step is to determine the maximum revenue and how to achieve it. So, this is very important to all businesses, maximizing revenue. So this is a good problem here. So how are you going to maximize revenue if this was or if this is our model right here? Well, we're going to first graph this. Alright, so go ahead and in your y equals, go to your y equals, enter this equation in. Alright. What you then want to do is go to your window and type in these values. Once those values are entered in, hit graph, and this is what you should see here. Something that looks like this. Now we want to calculate the maximum revenue, or we want to find the maximum value here. So we're going to go to second calc, go down to number 4 to maximum, then do the whole left bound, right bound thing. Alright, and we're going to get a maximum point where x is approximately 2.40 and y is approximately 88,227. Now, what does this mean? It means that you will achieve your maximum revenue of 88,000, because our y now is our r. We will achieve a maximum revenue of $88,227 when we're selling the cereal box at $2.40. Alright? Now, I hope that made some sense of those two example problems. Tomorrow in class we're going to go over example 8. It's going to be a lot easier to do this one in class. It's kind of detailed, a lot of different little steps. So just have those two examples done, and then we'll do example 8 in class and then get you started on the homework.